All right, so we're looking at page 57, section 3.3 about completing the square. We just talked about this definition. To complete the square, we're starting with the binomial. What's a binomial mean? We have how many terms? 2 terms. And we're going to turn it into a perfect square trinomial. What's a trinomial? 3 terms. Okay, so when we're completing the square, it tells us how to do it here. And this is why I asked you to do this in the warm-ups. You take b, you divide it by 2, and then you square it. Here they're showing you why this would work. That if we have x squared plus bx plus b over 2 squared, here's how it's always going to factor down. Okay? Let me show you how this would work, though, with some real values. So let's say we have x squared plus 18x. What would the number have to be to make this something that factors into a perfect square? 81, right? Because if this is 81, then when we go through and factor this, I say what times what is x squared? That's x and x. Then I look here and I say what numbers multiply to be 81? That's 9 and 9. And so then I need to get a positive 18, so that's plus and plus. But like I said, the way we're going to write that is x plus 9 quantity squared. And then I can hopefully get to where I can do this with a shortcut. So let's say we have x squared plus, let's say 6x. What would it have to be to make it so it's factorable like that? 9. And so now to do it the quick way, I can say the square root of this sign, and the square root of that. And that's how it's going to work. And the way that I knew it was going to work is because the square root of x squared is x. The square root of 9 is 3, and if I double that, because when I have my outers and inners, it's like I'm really doubling it. And so that would give me the 6x, so that's how I know that it does work. All right, let's do some examples now. So we're going to start up here. I check to see if it's a perfect square trinomial. I say, what's the square root? X. What's the square root? 2. If I multiply and double, I get that. So I know this can be factored. So to quickly factor it, I do the square root, this sign, and the square root has to equal this number. Now this should be a problem that I can now solve. It said to solve it using square roots. So if I have a quantity squared, to find out what the answer is going to be, I'm just going to take the square root of both sides. So I'm going to get x plus 2 equals plus or minus radical 2. Make sure you put the plus or minus. So now I would have to subtract 2 from both sides. And so x is going to equal, we typically want to put this first, because then we can say it's going to be negative 2 plus or minus radical 2. I want to show you how this could be checked. If I had gone to y equals, and I put in x squared plus 4x plus 4. What am I going to put into y2? I put this into y1. What am I going to put into y2? Just 2. I'm going to do a zoom 6. Here's the way that it looks. So the question is, when does this parabola equal 2? Well, it equals 2 there, and it equals 2 there. So watch what I do. Second, calculate, trace, intersect. I'm going to get close to it, this first one. I'm going to do enter, enter, enter. And it tells me this is the answer, negative 3.41. Now, if the problem was written exactly the way it is up here, you could give me that solution, negative 3.41. But if the direction said find the exact solution, if it said to find the exact solutions, these would be the exact solutions. But watch how I can check now. I go to my home screen. What is negative 2 minus radical 2? Oh, same exact thing, negative 3.41. See how I can check? So now I'm going to do the other one. Watch this too, guys. This is a nice trick to know. Just push second, enter, And now all I have to do is go back and change this from a minus to a plus, and I can get my other solution. So that's what I think the other solution should be. I can go back to my graph, and I can do second, calculate, number 5, get close to my other solution, do enter, 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 and yes, that was the same thing I had. All right? Makes sense? So these are the approximate solutions, and these are the exact solutions. All right, so from here on out, we're going to be finding exact solutions. I just wanted to show you how you could check. All right, so quickly on this one, what do? How do we factor it? Good. It's going to be t minus 20. Quantity squared equals 300. We're going to take the square root of both sides. So we're going to have t minus 20 equals the square root of 300. What's that going to be? Okay, 10 radical 3, good. And it's plus or minus. Then I want to take my 20 over. Be careful, what's it going to turn into if I take it to the other side? So it's going to be positive 20 plus or minus 10 radical 3. That's going to be our solution. All right, let's look at number 3. I check to see if it's a perfect square trinomial, and it is, because if I take the square root and double, I get that. So what's this going to be, Kelsey?
3w.
Good. And that's going to equal negative 18. So now I have to take the square root of both sides. All right, so I get this. Now, I'm going to get 3w plus 1 here. But what about when I do the square root here? What do I do if I have a square root of a negative? I have to make an I, right? And then how does 18 break down? It's 9 times 2, so square root of 9 is 3, so this would be written as 3i radical 2. The number comes first, the whole number comes first, then the I, then the radical. So now finishing this, I'm going to subtract 1. So I'm going to have 3w equals, I'm going to put this first though, negative 1 plus or minus 3i radical 2. Then I have to divide both sides by 3. So my final answer, both of these are getting divided by 3. So the best answer would be negative 1/3 plus or minus I radical 2. See what I'm doing there? We're saying this over this plus or minus this over this, and I can cancel those 3's out and just get the I radical 2. What that tells me when I get an answer like that is that this right here can never equal negative 18. That's why I got that imaginary answer. Doesn't it make sense that something squared will never equal a negative number? So that's the reason why we had to have an imaginary number, because that cannot happen. Okay? All right. Now all we're doing is we're finding what's the value of C that would make it a perfect square trinomial. So we take half and we square it. So what's this one, guys? Yep. Now this one, here's what I hear people do. They're like, oh, half of 17 is 8.5, or it's 8.5. You can't do that because it's too hard to square 8.5 or 8.5. So you want to write this as 17 over 2 squared. And this should be something that you can do. What is 17 squared? 289. And then 2 squared is 4. So it's 289 over 4. You should know the perfect square is up to 20. Okay? If you don't, it's not a big deal. You'll have a calculator to use. But really, like, you should know 15 squared is 225. 14 squared is, do you know 14 squared? 196. But if you don't, you can grab a calculator. Okay, so what's C going to be in this one? 144. Good. All right, so now we're going to be solving these equations by completing the square. So this is, completing the square is just another way to solve a quadratic equation. So if I want to solve this by completing the square, I'm going to keep the r squared here. I'm going to keep the 6r here. But I take the constant over to the other side. because I want to make this something that can be factored so that I can get parentheses squared. What would I add here to make it something that could be factored? Plus 9. If I add 9 to this side, I also have to add 9 to this side. See how now I haven't changed this equation? It's still equivalent. It's still the same thing, isn't it? Because if I add 9 here and add 9 here, I could subtract 9 and have the same exact thing. So now to finish, I think, how does this factor? I do the square root, the first sign, the square root. 2 plus 9 is 11. And now we're just back to these kind of problems that we did up here, where I'm going to take the square root of this side, the square root of that side. R minus 3 equals plus or minus radical 11. So R equals 3 plus or minus radical 11. Now, before we even start doing this, we should check to see if it can be factored. So I really should have said, are there numbers that multiply to be 2 and subtract to be 6? Multiply to be 2 would be 2 and 1. Do they subtract to be 6? No, so I had to use completing the square. Numbers that multiply to be 28, what are they? 4 and 7, do they add to be 10? Nope, so I'm going to have to complete the square again. All right, so we're going to have x squared plus 10x. Take the 28 over, it's negative 28. What are we going to have to add to both sides? 25. So you guys finish it now on your own. I'm going to do it up here, but I'm not going to talk you through it. Check your answer when you're finished. And here's what I want to show you. Here's this function. I just graphed it on the calculator. Does this function ever equal 0? No. And that's why I got an imaginary solution. Okay? What would you do first on number 9? Distribute. What I see people do sometimes is they're like, oh, wouldn't y have to be 3/4 and y plus 1 have to be 3/4? No. That only holds true on a problem like this. Watch this. If I have y times, say, y plus 1 equals 0. Well, now, because if two numbers multiply to give you 0, one of them must be 0. So y must be 0 or y plus 1 must be 0. So that would be the solution to something like this. But if two numbers multiply to be 3/4, does one of the numbers have to be 3/4? No. So we don't do that. So we distribute here. I'm going to keep the 3/4 where it is. Okay, now you have two options. You could get rid of the fraction by multiplying the whole thing through by 4, but it makes the problem a lot harder. I would keep it like this. So you're going to take half of 1 and square it, and what do you get? 1/4. So you're going to do 1/4 here and 1/4 here. So then the way that this is going to factor, square root, this sign, square root. What's the square root of 1/4? Square root of 1, square root of 4. 1/2. You guys see what we're doing? Square root of 1 is 1, square root of 4 is 2. That's all you have to do the square root. And then over here, we're going to get 1. So now I have to do the square root of both sides. Luke, will you close the door for me, please? So now we're going to have y equals negative 1/2 plus 1, and y equals negative 1/2 minus 1. So then what are our solutions then going to be? Where here is negative 1/2 plus 1, what is it? 1/2. Negative 1/2 minus 1? Negative 3/2. Very good. All right, we're not going to do number 10, but how could you make number 10 really easy from the start? Divided by 2. You always want to do that if you can. Okay, number 11 we are going to do because it has a little trick to it. First of all, no one should ever set 3x equal to negative 24 and this equal to negative 24. You can only do that if they multiply to be 0. If they multiply to be anything else, we have to distribute. So we're going to have 6x squared.
Can you divide by 3?
Yeah, but I'm going to wait till after I multiply it out, and then I will. So I'm going to multiply it out, and I get plus 30x. And I can actually divide through by what? 6. And I can get x squared plus 5x equals negative 4. Now, I want you to think about this. Do half of 5, which is 5 over 2, and then square it. I want you to do this step on your own. Figure it out. Megan, what are you going to add to both sides? Good. So we're going to add 25 over 4 to both sides. Well, if I want to add these two, what am I going to have to think of this as? 16 over 4. So what's negative 16 plus 25? 9/4. And now to finish this, I do it the quick way. Square root, first sign, square root. Take the square root of both sides. Take the square root, 3/2. And so now we're going to have 3/2 minus 5/2. We're not doing this one, so we'll just go over into this space. So what's 3/2 minus 5/2 going to give us? Negative 1. And what's negative 3/2 minus 5/2? Negative 8/2, which would be what? Negative 4. When I get nice answers like this, that means way back here, I want you to look back here for a minute, where I had x squared plus 5x equals negative 4. If I would have taken this over and checked this, are there numbers that multiply to be 4 and add to be 5? What are the numbers that multiply to be 4? Do they add to be 5? So that means that I could have just factored this. X, 4, 1, plus. See how I'd still get negative 1 and negative 4? That would have been the better way to do this problem. But I wanted to show you that sometimes we don't see it, but if we get answers like this, even answers like this, means that this could have been factored, but I don't think we would have recognized that one for sure. Okay. All right, number 13. This one's a tough one. It says, explain how this expression is a perfect square trinomial. Then write the expression as a square of a binomial. I want to give you a couple minutes to think about that. See if you can figure that out on your own. All right. Kelsey, you're the only person I saw to get this right. Can you explain to me what you did?
Yeah, well, first I like simplified to the parentheses, so it was 16p squared plus 1. Then,
Okay. When you did this, though, it's not really 16p squared plus 1 because you have to do 4p plus 1 times 4p plus 1. So it would be 16p squared plus 8p plus 1.
oh, okay, yeah, and then I did,
You distributed this.
8, yeah,
And what'd you get there?
32p plus 1. I mean, plus 8, sorry.
Right, that's okay. Good. Okay, and so then she just simplified all of this, and she had 16p squared plus 40p plus 25. I saw some of you got to this point, right? Okay, well now you just have to check it. What's the square root? 4p. What's the square root? 5. You multiply those and double, and do you get this? If you multiply these two, you get 20p and double. Is it the same as that? So that tells me that it can be factored quickly by doing the square root, this sign, square root. And that's our answer. Now, I want to show you something else though. What if instead of these being 4p plus 1, what if this had been x squared plus 8x plus 16? So I'm saying instead of using this, I'm using x. I'm using an x here and an x here. How would this factor? How does this factor? X plus 4 squared. Well, our problem though, we don't just have an x here. So what do I need to replace this x with? What is x here? 4p plus 1 plus 4 squared. Do you see how that's going to end up giving us the 4p plus 5 squared that way too? See that? Because this is really x squared plus 8x plus 16. X squared plus 8x plus 16 is x plus 4 squared. But we're not using an x. We're using 4p plus 1. So I had to replace x with 4p plus 1. Then I still had the plus 4, and I get the same answer. So you could have either multiplied it out, like a lot of you did, or you could have just gone directly to noticing that. Okay? All right, we're going to stop there for a minute, and we're going to look at our homework, and then we'll continue and finish these.